Today I'm going to show how to integrate one of the things that appeared in the Gauss's law chapter. So let me write down the integral. So the integral was the following. It was r squared dr divided by r plus c. Okay. And you can check out the video that I had here. In that video, I just showed you what this integral was equal to. Here, I'm going to derive you. Let me first talk about the systematic way of doing that. You don't want r plus c's and things like that on the denominator. What you want instead is actually a polynomial on the top and maybe just an r at the bottom. U equal to r plus c, you make this change of variable, and hence du is equal to dr. And then rewrite this integral as, then you see if u is equal to r plus c, r is equal to u minus c. And this will be u minus c squared, and dr is equal to du. And now instead of r plus c, you just have u. And now you have multiple terms in here, and that will be equal to, so let me write it here, u squared minus 2uc plus c squared. And all divided by u. And then if you do the cancellations for this, that's going to go away, that's going to go away, and this is going to be c squared over u. So this integral will be u times du. That's one integral, that's this term. And minus, you have 2c times du, just a constant. And I have c squared du divided by u. So you will have three different terms in the integral, and each can be integrated easily. And this is going to be u squared divided by u. D squared divided by 2, that's the first term. Minus 2c goes out of the integral, so you have 2c. And du just gives you u. And the final term will be plus c squared, and du over u is a logarithm, right? Logarithm of u. And then you go back to the original variable, which was r. Wherever you see u, you replace it with r plus c. So this becomes r plus c squared divided by 2. And then minus 2c, u becomes r plus c. And the final term will be c squared logarithm of r plus c. And then one last thing that you do is you want to express in terms of like r's and r squares and constant terms and this logarithm term. And to do that, you expand this r plus c as r squared plus 2rc plus c squared, now all divided by 2. And this is going to be minus 2cr. So that's minus 2c squared. Plus the last term does not change, logarithm of r plus c. Okay, so now you see the first term, which is at the order of r squared, is r squared over 2. The second term, you see 2 cancels 2, you get rc here. And you get minus 2rc from here. And you get plus c squared over 2 minus 2c squared plus the final term. Okay, now this cancels that. And the result that you get is r squared over 2 minus rc plus the logarithm term, which is c squared logarithm of r plus c, plus some constant of integration. So it wouldn't matter if you have like c squared over 2c squared, because there are already other constants, because this is an indefinite integral, right? So there are some constants, and that's how you do it. So this is like the systematic way of doing that. You make the change of variables so that you will only have u here and some polynomials in there. And each of those polynomials will give you some, a less, so if it's u, then it's going to be u squared over 2. If you have higher powers, then you just integrate it one by one. And the only non-trivial, it's still, not a difficult integral, is du over u, and because that gives you a logarithm. So that's like the systematic way of doing that for all these type of things. But for this particular thing, you can actually make something nice. You can express this in a better form. So this is now the physicist way of doing that. Feynman really enjoyed doing this stuff. as well as other physicists, and I also had the privilege of working with some of those. And so this is r squared over r plus c. I mean, it's not a big trick, but still, I'm going to call it a trick. So r squared plus r plus c is equal to, you just subtract and add c squared. And it will be clear why I'm doing that. And even at this stage, it might be for some of you guys. And you see, this has two parts, this and that. So let me write it like that. So this is equal to r squared minus c squared divided by r plus c. I'm just, separating these two, and c squared plus r plus c. And why am I doing it? I think it's clear. This has r minus c and r plus c, and that's going to cancel that, right? Now you can see there is a nice cancellation, as I just said. R plus c terms cancel each other, right? And all of this expression becomes, so that becomes actually r minus c, which is this term, plus c squared divided by r plus c. Now it's a very easy integral to do, so let me now put all of that in here, and I'm going to write it with this pink guy. So I have r term minus c term plus c squared divided by r plus c term, and I'm going to integrate that with respect to r. And the first term is going to give me, let me even write it here, the first term is going to give me r squared over 2. The second is going to give me r times c, or c times r. And the last term is going to give me c squared as a constant. And the r over r plus c is logarithm of r plus c. So you see this integral, so both. This is the integral r squared dr divided by r plus c. Okay, you can either do it that way, or you can just use this nice trick of expressing that in terms of two different terms in here and then integrating like that and giving you exactly the same thing. Of course, there is a constant, which is undetermined constant because this is an indefinite integral.